Hello, everybody. We will continue with the next presentation. Our next speaker is Jakub Stehlik, and the topic is Discovering Atlantis, Information as a Code Automation Workflow. It's all yours.
Thank you very much. 1, 2. Okay, we can hear each other. So, hello everyone. My name is Jakub, and today I will tell you how we automated our infrastructure as code workflow at Labyrinth Labs. So first, who is Labyrinth Labs? We're a group of 20 people who work with clouds, cloud-native tools, and Kubernetes. And our main mission is to bring the joy and magic of these technologies to our clients, to make them cloud-native and to make them future-ready. But enough with the sales pitch, let's get to it. CloudFormation, Pulumi, CDK, Ansible, there are tons of infrastructure as code tools in the market, but whether you like it or not, the most popular right now is still Terraform. And since it's popular, new companies tend to try to adopt it, and if they are not experienced with it, it has some interesting consequences. Let's see what consequences. So let's imagine I'm a developer at a company. I don't have Terraform installed on my computer. I need to make a change to an API, which is deployed via Terraform. So what do? I find a DevOps engineer. I ask him to do the change for me. Afterwards, he applies the change from his computer. And then, since we are following standards and it's infrastructure as code, it's code, he pushes the code to Git. Sounds good, right? Not really. Let's see why. So first, I have to chase down a DevOps engineer. He's being chased down by 5 other people. He has other work to do. He's at lunch. He's on holiday. I have to rely on somebody else to do my work for me. It's not ideal at all. Second, he applies the change from his computer. This is the Terraform equivalent of it runs on my machine. Different people may have different versions of Terraform installed. Different OSs can make changes to the end output of Terraform. And thus, we don't always get a consistent result. And last but not least, he stores the change in Git. But does he? Right here, it's an afterthought, and things like these get forgotten. People forget to push pull requests, to push things into Git. People overwrite their work and other people's work. So the situation is not ideal at all. So let's imagine for a moment a world where these problems don't exist. What if I, as a developer, could deploy these things on my own without having to chase down other people? What if I could have some standard tooling or standard running environment where I could run my Terraform plans and applies, and I would always get a consistent result? And what if I can make sure that I'm always working with the latest applied infrastructure and the latest applied code? What if I can make sure that I'm not stepping on the toes of other people and that they are not in turn overwriting my work? And the answer, of course, is CI/CD. In this case, for the sake of this presentation, a nifty little tool called Atlantis. Atlantis is simply an open source CD tool for Terraform. Its main gimmick is that it works with pull requests and supports Terraform, CDKTF, and Terragrunt, which is like a soft wrapper around Terraform. How does it work? So you have Atlantis deployed somewhere as a server. And it has to have a URL, and you configure that the URL is a webhook in your favorite Git provider, so GitHub, GitLab, Azure DevOps, Bitbucket. And then when you make a pull request with a Terraform change, the pull request sends the request back to Atlantis, sends the request to Atlantis. Atlantis runs the plan for you and posts the result back into the pull request as a comment. And if you are happy with it, you can type in Atlantis apply, same flow, gets to the server, Atlantis applies it, and post the results back into the pull request. So let's try a quick demonstration. If it doesn't work, I'm just going to show you pictures. So since this is a Kubernetes conference, I'm going to try to deploy a Kubernetes namespace into one of our clusters. So right now I'm running Atlantis here on my computer. I'm assigning it a URL via ngrok, and I have a pull request a branch pre-prepared. So let's create a pull request. I'm happy with it. So let me quickly show you what changed. So I added a Kubernetes namespace. KCD is awesome. And as you can see, it's trying to run an Atlantis plan. So I hope I configured the webhook correctly. We can maybe see here. Yep, it got it, so it should work. And here I have the result of the plan. And here I can see what changed. So it wants to add resource, a Kubernetes namespace into my cluster. So how do I apply this? Well, I can merge pull request, but that wouldn't work. I can type it Atlantis apply. And what's going to happen, it tries to run the apply. And after it finishes, we should see a beautiful new namespace in my Kubernetes cluster, which is right around here. And it's that. So this is basically what Atlantis does. But you can say, okay, this is cool, but how does it solve my problems? How does it solve my problems? So let's go over it from the back. I want the latest applied version of the code. I want the latest applied Git. Atlantis is GitOps. The Git isn't an afterthought. It's the trigger for what you want. So you control everything via pull requests. Atlantis implements certain locking, which means that the first person who makes the pull request basically prevents other people from changing the same state until he finishes his work, until he unlocks it or merges the request. In order to make sure that everything is up to date, for example, the master branch is up to date, Atlantis can also auto-merge things for you, or auto-merge the pull request for you after it's applied. Second, standard tooling. Atlantis is released as a container, so you can always rely, when it's running somewhere in the cloud or wherever, you can always count on the fact that it will be consistent. Additionally, you can pin a specific Terraform version to use. So you can always be sure that you are running a certain version of Terraform and that you have a consistent environment and a consistent output. Last but not least, can you do things on my own with this? Yes, if you have access to Git, it's a CI/CD tool. So anyone who has access to Git can go there, can make that change, which might not always be ideal because you also want to control if someone does something. So again, pull requests. People check the pull request. Atlantis can be configured for approvals. It won't run and apply until the pull request is approved. And you can always be sure that you can do it basically on your own, just maybe with a review if you want extra control. But wait, there's more. Some other functionality that we found in Atlantis is that, for example, you can do Terraform state chaining. So you apply it in one place, and then another in one pull request, and do them in order. You can also implement custom workflows. For example, for the examples from documentation are rule validation via conf test, I think, or finding out the cost of your Terraform plan or of your infrastructure with infracost. Also, Atlantis can delete the branch that it merges for you so that you have a clean Git repo. Atlantis is an awesome tool, but you also need to make sure it runs well. You need to maybe change your IaC, and you can maybe expand your automation with other tools. Let's start with the architecture. So at Labyrinth Labs, we run Atlantis from a central EKS cluster, but we have multiple accounts that we control, multiple AWS accounts that we control. So first we have to make sure that Atlantis has access to all the places where it needs to go. When we are running in production environment, we of course want some high availability, because if Atlantis just wants a server, it doesn't spawn runners, it actually runs as a server. So when you have Atlantis as in a highly available setup, you need to make sure two things, basically. First is that all the servers have access to the same file system, where they clone the repos and on which they run the Terraform plans and applies. Second thing is the locking mechanism. We want all of the servers to know where the locks are located. So normally, right now, when I'm running here, database is local, but normally there is a Redis database that you connect it to, and all Atlantis servers know about the locks. When we deploy it via Helm chart with Terraform, which brings us into a kind of a chicken egg problem, because, okay, we have Atlantis to deploy Terraform, but we need Terraform to deploy Atlantis. So first, there needs to be some initialization workflow. We need to do some things manually. We need to set things up manually before Atlantis can run itself. And second thing, can Atlantis, when it's deployed with Terraform, update itself? Yes, it can. However, there is a caveat, it needs to make sure that the plan or that the apply doesn't kill the server that's actually running it, because you may actually end up with an inconsistent result, and we don't want that. From the point of view of infrastructure as code, so when you want people to use your Terraform modules or whatever you use, the backend, the modules, the code itself can be as complicated as you want. However, for the users, you need to make sure that there is a clear separation between code and configuration. The configuration should be simple, it should be well documented, it should be easily usable, and the users should be able to find it very easily in the Git repos. With Atlantis, you also need to consider whether you are running in a monorepo or multiple repositories. So Atlantis thrives in the monorepo, absolutely loves it. And here's why. So let's say I have a repository where I have all my Terraform code, and I have a directory called modules, and another directory called, and where I actually deploy those modules. So the modules contain common code, and the environments deploy it and call it. So when you have a monorepo with Atlantis, what you can do is set the source for that module in as a direct path. And when you do that, Atlantis is able to detect that when you change the module, it detects, okay, it's supposed to be deployed here everywhere. So it runs in the same pull request for the module. It runs Terraform on the dev environment in this case. I think it does it automatically. I'm not sure right now, sorry. But I'm certain what I mostly use is a configuration file called atlantis.yaml where you can configure the different environments. What this file is showing is plan the env dev and auto-plan it when either the Terraform files in it are modified or any other Terraform files in module 1 or module 2. So that's where Atlantis works absolutely well. It can change these things together. When we are running with multiple repos, which is common practice because monorepos can get big, it's not ideal. The common practice is to separate common modules into separate repositories. And what the flow that is there is that you release the module, you tag it, and then in the central module, you reference the URL, whatever, with the certain version. Unfortunately, in this case, you can't do such things like you update the module and won't automatically run something in the other repo. So you need to create the pull request in the central repo to make it happen. So what are the best practices here? Even though you can have chaining like here, or you can have things in multiple repos, even when you have one repo, you might not always want to use the direct source. And there are two reasons for that. First reason, if you have multiple environments configured like this, you have maybe 50 environments or whatever that you have configured in this first place. When you create the pull request on the module, you essentially lock all of them at the same time, which can be really tedious because you can't merge the pull request until you get them all up to date and until you apply them. Second reason is the difference between dev and production. So some environments you want to be up to date, you want them to be on the latest version. So immediately after you change the module, you want them to get updated. That's dev environments, sandbox environments. But for production, you might actually want to control when and what things are going to be there. So even if you are in the monorepo and have your modules in the monorepo, you might want to use tagging. So in the monorepo, you just tag the specific commit and then use it and then use the reference. Now, when you have multiple environments, a lot of environments, and you want to change things in all of those environments, especially when you have it done in the tagged way, it might be tedious to create all those pull requests for all these environments and find where you are using the module everywhere. It's not ideal. So how would you automate that? Dependabot, Renovate are cute little tools that can help you with this. So how do they work? Dependabot and Renovate sees that there is a module release, either in your repo or somewhere else. So my module increased from 1.0.2.1.2, and creates a PR in the repo where it updates it and creates the PR for that. And when we have the PR, it runs Atlantis. You have it planned, and you have it pre-prepared, and you don't have to search for it like crazy. That's around Atlantis, but you might also want to automate the code or pushing the code into Git itself. And a great tool for that is pre-commit. So what can pre-commit do? Or how does it work? Pre-commit first, when you commit a change, it runs some arbitrary script. And if they pass, it allows you to commit. Otherwise, it makes you fix the things that don't pass. So what you can use it for is you can format your code. So no more searching for spaces yourself. You can let it do it for you. It can lint the code according to best practices. It can detect secrets or run some security checks to make sure that your IaC code doesn't break anything or that it's actually secure. And of course, it can generate documentation for you so it doesn't have to do it manually, which can be really tedious. And this way, you can make sure that the code that actually runs with the other automations is pristine and awesome. Atlantis itself is just one CI/CD tool for Terraform. There are many others. So let's go down the list of what they are. First, using native Git workflows, GitHub Actions, GitLab pipelines, I think you call them, for example. What's really awesome about these things is that you are working at the source, at the Git provider itself. You are not relying on an external tool. You are relying on the functionality there. So for example, if GitLab updates its API, Atlantis may take a little while until it implements that change into its code base. So the problem appears when you want to implement complex functionality. For example, state chaining, or even finding which directory is changed. Is not so easy to script, possibly, and Atlantis has it already inside as basic functionality. Where there is an open source solution, there's going to be a software as a service offering, and this is no different. So the alternatives from Atlantis in this space are, for example, Terraform Cloud, Spacelift, that's that thing right there, and N0. One of the pros of these things, they usually have awesome UIs. They have extensive APIs, which you can connect with your other internal developer platform tools or whatever you want to use. They usually implement role-based access, which Atlantis doesn't have by default, unfortunately. And the advanced functionality that you have to configure in Atlantis is already part of these tools. So for example, figuring out costs, I think, is part of Terraform Cloud already. The cons, the obvious one, they may get expensive, like really, really, really expensive. So always, when you are choosing a CI/CD tool for Terraform, figure out what is less expensive for you. Do you prefer a managed service, or is it much less expensive to run your own infrastructure, scale it on your own, and so on? And lastly, a bit of a black sheep here, and I may regret talking about this one, is Crossplane. So Crossplane isn't really an alternative to Atlantis itself, but maybe an alternative to Terraform. And the reason I'm talking about is here that with Crossplane, which is the Kubernetes way of deploying infrastructure, so you can define your infrastructure as code in manifests, and Crossplane deploys it for you. So you can tap into the Kubernetes workflow. You can use Helm, Customize, Argo CD, Flux, and use all the advantages that come with it. Crossplane, compared to Terraform, is relatively young. It has probably a bright future, we'll see. But for more complex things, I would still prefer to use Terraform in this place and in the workflow perspective, Atlantis. Well, that was quite short. Thank you very much. If you'd like to contact me, please send me an email. I think that QR code is going to take you to a labyrinth like LinkedIn, where we post cool stuff about Kubernetes, cloud-native things, and so on. And if there are any questions?
Oh yeah, there are many.
Wow.
Okay, let's start up with the first one, the most popular one. What's the additional value over Terraform Cloud except running it on our own server?
I think that's the main value. I think Terraform Cloud had a free version that they limited recently, so you can have only 500 resources free or something like that, which means that you have bigger infrastructure, you suddenly have to pay. So yeah, I think that's the main thing, that you can run it on your own, you can control it. I'm not sure if you can self-host Terraform Cloud. You can self-host Atlantis, and if you are in an air-gapped environment and you deploy it there, it can communicate with your GitLab repo or something.
Next question, does it always need to write Atlantis apply, or can it be automatic with merge?
Can be automated.
Well, whether you need to write that comment.
This was one of my first grabs with Atlantis, because the automation I was working with before was first merge the main, so the main is up to date, and then whether it's broken or not, then it runs. Atlantis has it the other way around, so first you apply it, and then it merges. So you can't do that. Perhaps you can make some kind of automation, because Atlantis also has a simple API. It's not as extensive as, I think, Spacelift or Pulumi or whatever, but you can use it to plan and apply. So theoretically, you could do something. You could do merge, webhook to something else, to your own tool, which will then trigger API on Atlantis, and that's how you could make this workflow work, I think. Haven't tested it yet, so maybe try it out.
Thank you. How do I run Terraform destroy?
Okay, I'm gonna have to check the documentation on this. So let me see. I know Atlantis has plan, apply, it has import. I'm not sure if it has destroy, I never ran it. So I think you don't. So how I would normally destroy resources is I would comment them in my workflow, and then apply them, and then apply it, and it will destroy those resources. So I'm not sure if I've never used it in this way, unfortunately, or fortunately.
Thank you. What about big TerraGrant repositories for a whole cluster? Is it possible to apply just one specific folder?
I think yes. So with TerraGrant, you first of all need to get it into the image. So you need to create a custom image. Terraform is quite light in itself. It doesn't have any AWS CLI or kubectl or other tools that you might actually use. So first you would need to create your own image. And in this case, I think you can. So you can specify which environment you want, which environment will trigger the change, and that's where it's going to run.
Next question, why should I choose Terraform and Atlantis for deploying apps to Kubernetes instead of tools like Argo CDN or Flux?
So it's not, Terraform and Atlantis in this case aren't a replacement for that. They're a great complement. So how we use it at Labyrinth Labs, we have Terraform code, which we use to spawn infrastructure, and we use it to trigger Argo CD or deploy the Helm releases themselves. So it registers the change in Argo CD, and Argo CD does the rest of the work. And Terraform itself, for us at least, is the central or a common language that we use for configuring all of these things. And we can thus control it all from a central place. That's the advantage for us. So it doesn't replace it, you can, however, integrate it.
Thank you. And since I am allowing the developers to make changes to the Terraform, how can I prevent them from modifying certain parts with Atlantis while allowing the rest?
This is important. Atlantis has configurations for allowing apply of requests that are approved or mergeable. Mergeable is conditional depending on what it means in each Git provider. GitHub and GitLab have different conditions. But approved means that unless somebody approves it, then they can't change it. So if you, for example, configure code owners in GitHub or GitLab, you can make sure that unless it's approved by the code owner, no one else can apply it. So the developer can try, but he won't actually get to do it.
Thank you. And the last question so far, what can Atlantis handle that GitHub Actions cannot simply do?
As I was talking about the complex functionality, for example. So GitHub Actions are a viable alternative, but when you want complex functionality, like infra cost, state chaining, locking, it can be done possibly with GitHub Actions, but it's not as easy to do as with Atlantis or any other managed or pre-prepared tool.
That was the last question. If there are no more questions, we still have some time. Doesn't look like it. Thank you very much. It was a great presentation. I really enjoyed it. Thank you.
Thank you.